Okay, one more example before we move on. A little bit different. We've got a limit. Now this time the variable is h tending towards 0, and I've got the function of 2 brackets x plus h squared minus 2x squared over h. Don't let the two different variables throw you off, okay? I know it looks a little bit confusing, but just know this. Because of the two different variables, you're going to land up with an answer in terms of x, okay? So h is the value for x to which that we're tending towards, but you're still going to land up with this x in your answer. So just expect that. That's what's going to happen here, okay? Right off the bat, if I look at h tending towards 0, if I were to substitute 0 into this equation as it is right now, boom, I'm sitting with a denominator of 0, undefined, okay? And we're pretty much stuck at that point, okay? So what do we need to do? We need to try and factorize the top. Here it's only going to be able to be the top, so that we can somehow cancel that h out in the denominator, because as soon as we can cancel it, we get rid of that problem of the denominator being 0. Okay, so let's see. We're going to have to say limits of h tending towards 0, because as I said in the other example, that needs to stay there until we're ready to substitute it into the equation, okay? Right, what am I going to do here? A little bit of tidying up. If I'm squaring a bracket, it means that I am writing the bracket out twice, okay? So to write it out twice, and you're actually foiling it. By foiling it, we're going to get x squared plus 2xh plus h squared. Okay, I didn't actually show that FOIL. You can do it for yourself, but that's what you're going to land up with. Minus 2x squared. All right. We've got this line. And it's all over h. Okay, can I take out, or can I somehow factor the top yet? No, I can't. I'm going to have to take another step of tidying up. We've got our limit as h is tending towards 0. Distribute your 2 into the bracket. So I'm sitting with 4xh. I'm sitting with 2h squared minus 2x squared. It's all over h, okay? Right, at this point, I hope you can see that we got a little bit of tidying up to do in the fact that that 2x squared there and that 2x squared there are going to actually cancel each other out. That's good news for us, because by canceling those out, do you spot that both terms have got a highest common, or a common factor of h, all right? And if they've both got a common factor of h, well, that means that we can take it out. We can factorize it. So our limit as h is tending towards 0, so we're still keeping it there because we haven't subbed it into the equation yet. H is coming out now as your common factor. So that's now leaving you with 4x minus 2h, and it's sitting over h. Okay. Can you see now that by that manipulation, by simplifying it, by factorizing it, I can now cancel those h's, and that's exactly what you wanted, because now you are able to substitute your 0 into the equation. And this is the point at which we stop saying limit, we just say equals, and we say 4x minus 2 times by 0. And we get 4x. Now remember, I said to you in the beginning, you're going to land up with a limit that's in terms of x. That's fine. Okay, no worries. Don't stress about that. That's just your solution. So as your value of h tends towards x of that particular function, the y value tended towards 4x, and that was your limit. All right. I hope you understand that, and I hope limits are clear to you, because we're going to move on to the whole wide world of calculus, which has a lot to do with this. All right, see you then.